Chapter 6. Arrays. Understanding the concept of arrays. An array is a collection of elements that are stored in a contiguous memory location and have the same data type. Arrays allow us to store multiple values of the same data type under a single variable name. They are used to efficiently manage and manipulate large sets of data. However, in Python, the built-in data structure that represents an array like object is called a list. Lists in Python are similar to arrays in other programming languages, but they provide more flexibility and functionality. Here are some arrays lists work in Python. First, declaring an array list. To create an array list in Python, you simply use square brackets and separate the elements with commas. For example, second, accessing elements. You can access individual elements in the array using their index. The index starts from 0 for the first element, 1 for the second, and so on. For example, third, modifying elements. You can modify the elements of the array by assigning new values to them using their index. For example, fourth, array length. You can find the number of elements in an array using the len function. For example, fifth, array slicing. Array slicing allows you to create a new array, sub-array, by extracting elements from the original array. It is done using the start, stop, step notation. For example, sixth, array operations. Python lists provide various methods for array manipulation, such as adding elements, removing elements, sorting, reversing, etc. Seventh, multi-dimensional arrays. You can create arrays of arrays to represent multi-dimensional data structures like matrices. For example, arrays, lists are dynamic data structures in Python, meaning they can change in size during program execution. This flexibility and ease of use making them widely used for data manipulation, storage, and processing in Python programming. Limitations of an array. Arrays have several limitations. First, fixed size. In Python, lists are dynamic and can change in size during runtime. But arrays in many other programming languages have a fixed size. Once an array is created, its size cannot be changed. And you may need to create a new array with a different size if you want to store more elements. Second, homogeneous elements. Arrays can only store elements of the same data type. In Python lists, this limitation is somewhat relaxed as they allow storing elements of different data types. But traditional arrays in other languages strictly require homogeneous elements. Third, inefficient insertions and deletions. Inserting or deleting elements in an array can be inefficient, especially when dealing with large arrays. If an element is inserted in the middle of the array, all elements after that position must be shifted, which takes linear time complexity. Similarly, deleting an element also requires shifting the subsequent elements. Fourth, memory wastage. Arrays are contiguous blocks of memory, so they may lead to memory wastage. For example, if an array is declared with a large size but stores only a few elements, the remaining memory space is wasted. Fifth, no built-in bounds checking. In some programming languages, arrays do not perform bounds checking by default. If you try to access an element outside the valid index range, it may lead to unexpected behavior or even crash the program. Sixth, lacks dynamic method. Arrays lack built-in dynamic methods for common operations like sorting, filtering, or mapping. While Python lists provide these methods, traditional arrays in other languages may require writing custom implementations. 7th, limited functionality. Compared to the other advanced data structures like linked lists or trees, arrays have limited functionality. They cannot efficiently perform certain operations, such as inserting an element in constant time or searching for an element without linear time complexity. 8th, single dimensional. Traditional arrays are single dimensional data structures, meaning they can store elements in a linear sequence. More complex data structures like multi-dimensional arrays or matrices may require additional logic to implement. Despite these limitations, arrays, lists in Python are still widely used due to their simplicity and efficiency for certain tasks. However, for more complex data manipulation or when dealing with large-scale applications, other data structures might be preferred. Let's represent a simple one-dimensional array with a diagram. In this example, we will create an array of integers. Array 10, 20, 30, 40, 50. Here is a diagrammatic representation of the array. Explanation. The array contains 5 elements: 10, 20, 30, 40 and 50. Each element is stored at a specific index. Indexing starts from 0 for the first element, 1 for the second and so on. The element 10 is stored at index 0, 20 at index 1, 30 at index 2, 40 at index 3 and 50 at index 4. The diagram visually represents the array as a row of cells, where each cell represents an element and its corresponding index. Let's create a diagrammatic representation of a simple two-dimensional 2D array, also known as a matrix. In this example, we will create a 3 × 3 matrix with integer values.